Okay, so we're going to run through the homework real quick. This one can be done with the PowerPoint, and you can get the answers from the PowerPoint or the video that I did. Um, so to do this one, it says, is this statement true? If you've got x, p, this is the important part. We want this, and we want to compare it to that. So if we have p is 3 less than or equal to x is less than 7. Remember, this is an approximation, so since this is less than or equal to, if we have the 3 here, and if we have 7, less than or equal to means we're going to want this to be between 3 and 7. However, since it's an approximation, we want to make sure this one includes 3, this one does not include 7. So to do this, if we want to include 3, we're going to go a little bit to the left to 2.5, and we're going to have 2.5 be the lower boundary. And then since we don't want to include 7, we want to get something before 7, which is 6.5. You're always just going to subtract 0.5 or add 0.5. And so we want between that and 6.5. And so when we look at the answer, it says between 3.5 and 7.5, so that's false. Check the answer. And next question. So that's the important part, knowing how to round. On this one, we says describe the area of the curve. The probability that at least 36 have a gas stove. So P of x is less than or equal to 36. That's at least. If we're going to do this, then we have our curve. Here's 36. We want to make sure 36 is included, so we go a little bit to the right, and that's 36.5. And we want everything to the left of that, so if we look at the answers, area to the left of 36.5, oops. Wait. Probability that at least, oh, I'm sorry. Okay, so it does give different answers. I wasn't paying attention. P of x is at least is greater than or equal to 36.5. 36. And so what we want to do here is we want to, so let me redraw this. I apologize. I didn't realize that this had more than one solution. Here's 36. We want to make sure that's included, but we went greater than, so we want to go to the left, 35.5. We want everything to the right of 35.5. So area to the right of 35.5, check the answer, and we're good to go. Sorry about that. I didn't realize it switches questions. There's multiple questions. The other one I was doing was the other one, so I didn't think anything of it. What is the area under the normal curve? That there are exactly 17. So this one's a little bit more different. So we have P of x being equal to 17. So you've got your curve. Here's 17, doesn't matter where. We can approximate it if we go 16.5, 17.5. And so between 16.5 and 17.5, we check the answer and we got the answer right. So that's one nice thing about this. It allows us to do when it's equal to. This one will be, notice it says 12 and 28, so I'll give you a hint. And it says inclusive. This is the probability that 12 is less than or equal to x is less than or equal to 28, I think it was. Make sure. Yeah. So obviously you're going to underestimate 12. You're going to overestimate 28 because we want to make sure they're included. So go ahead and try that one. For this one, compute P of x. So they're going to have you do the binomial theorem on this first part. So we're going to have to use the binomial theorem. Remember the binomial theorem. If you forget, you can look up here. Actually, we can just use the video. So remember, it's n choose r times, that looks like an h. It's n choose r. It's just getting worse. Hold on. N choose r times p to the n times q to, the thing's going to say 1 minus p, which is q, to the n minus r, I think it is. Something like that. So I'll show you how to do this real quick. In this case, they give us n is 59. Choose, and they want us to do probability of getting exactly 19, so choose 19. And this is what we did in class the other day. So P is 0.5, so we want 0.5 to the 19 times n 1 minus 0.5 is going to be 0.5 again to the, so I'll write it out for you just so you can see it. 1 minus 0.5. 59 minus 19. Okay, so that's 40. So if we use the calculator, we're going to do math, probability, enter, oops, math, 59, 19 times 0.5 raised to the 19 times 1 minus 0.5 raised to the 59 minus 19, that's 40. I could just put that 0.0024, so we're going to enter that. Okay, so can the normal approximation be used? You just do n times p times q, so this is going to be 0.5 times 0.5 is 0.25. 1/4 of 59 is 1/4 of 60 is 15, so that's bigger than it, so yes. Oops. Oh, I'm sorry, not square root. Sorry. N times p times q. Sorry about that. I didn't even notice that. Then if we want to approximate it, we're going to go second. This is the important part. It's normal CDF. Okay, we're going to use, so we want 19, right? So if we drew the picture, here's 19. We want exactly 19, so we're going to use 18.5 and 19.5. That's our lower and upper boundary. Oops. Look at this. 18.5, 19.5. We want 59 times 0.5. And then we want square root of 59 times 0.5 times 0.5. This is n times p times q. Square root of n times p times q is the standard deviation. We enter. We get 0.0025. So if we enter that, 0.0025, you can see just how close this is. And it says how much do the exact and approximate values differ? So just subtract them, 0.0001. So that's how little of a difference there is. And you can go to the next question. Okay, so that's how you do these two. And then, yeah, I think you're going to have to do those three actually. This one is going to be kind of the best practice probably for the approximating. Obviously, for exactly 187, you're going to use the boundaries 86.5 and 87.5. At least 87.5 means you want p of x less than greater than or equal to 187.5. So you're going to overestimate. You'll use 186.5 to infinity or whatever, or a big number. Fewer than 164, that means 163.5 and less, so anything to the left of that. And then between here and here, inclusive means less than or equal to 164 and 168. You're going to want to underestimate this one, so 163.5 and 168.5 on the boundaries. And you're just going to use the calculator on all of these. And you have to use the 88%, the n times p times q, and use that in the calculator to get the standard deviation and the mean. I hope this helps, guys. Thank you for watching. Hopefully you can get the homework done. Thanks.